Good morning all. Today we will discuss about the erosion operation. The symbol of erosion operation, it is represented like this. And the very basic definition of erosion operation, it is given like this. X erosion with B, it represent all the point P in two-dimensional space such that P plus B belongs to X for all B belongs to the capital B. This X, it represent my input image. This B, it is my structuring element. So image set X erosion with the structuring element B, it represent all the point P in two-dimensional space such that P plus B, vector addition between P and B, it belongs to the image set X for all elements of small b belongs to the structuring element B. So what does it represent? Let us discuss with an example. So consider the example 1. This is my input image. This X, it is my input image. This shaded portion are my object pixels, and this represent my origin. So first of all I will mark the indexing. Since this is the origin, so we will start our indexing from this origin. Let's suppose this is my X direction and this is my Y direction. So we will start our indexing from this origin. So it start like this: 0, 1, 2, 3, 4, 5, 6, 7 along the X direction. Similarly along the Y direction it is 0, 1, 2, 3, 4, 5, 6, 7. The input image X, it having the dimension 8 cross 8. So in order to draw the erosion output between X and B, here I also draw a 8 cross 8 output image. So same indexing we will follow in this output image also, considering this is my X direction, considering this is my Y direction. Same indexing we will follow: 0, 1, 2, 3, 4, 5, 6, 7, and along the Y 0, 1, 2, 3, 4, 5, 6, 7. So usually in erosion we have to check whether the object pixel of the input image X, it would be a part of the eroded output or not. So for all object pixels, we have to check whether the object pixel it would be a part of the eroded output or not. So among all these object pixels, let us examine this pixel first. So we will examine this pixel first, mark it as the pixel P, and the coordinate of this pixel P along X it is 4, along Y it is 6. So I will write the coordinate of P as 4, 6. Right. Now look at the structuring element. In this structuring element, this is my origin. Okay. And this origin, it is of shaded pixels. Similarly, this right side pixel, it is of shaded pixels, and this left side pixel, it is also a shaded pixel. So for this structuring element B, I have 3 pixels: center pixel, right side pixel, and the left side pixels. Okay, so now we will write the set of this structuring element B. So now we will write the set for the structuring element B. So the structuring element set B, it consists of 3 pixels. First the center pixel, which is 0, 0. The pixel which is the left side of this center pixel. So if this is 0, 0, this would be -1, 0. and this right side pixel, if this is 0, 0, the coordinate of this pixel, it is 1, 0. Okay. So first we will check this pixel P having the coordinate 4, 6. So P having the coordinate 4, 6, and we have to do the vector addition of 4, 6 with this 3 pixel minus 1, 0, 0, 0 and 1, 0. So 4, 6, when we perform the vector addition with minus 1, 0, my result would be 3, 6. Similarly, 4, 6 on vector addition with 0, 0, it gives the result 4, 6. And when 4, 6 we perform the vector addition with 1, 0, it gives me the output 5, 6. Right? Now we will check these 3 pixels 3, 6, 4, 6 and 5, 6 whether it is a part of the object pixel or not. So first for the 3, 6, along x it is 3, along y it is 6. So along x it is 3, along y it is 6. So 3, 6 it is a part of the object pixel. What about 4, 6? Obviously 4, 6 it is a part of the object pixel. And what about 5, 6? Along x it is 5, along y it is 6. 5, 6 it is not the part of the object pixel. So what is my conclusion? P 4, 6 doesn't satisfy the criteria for all the doesn't satisfy the criteria. 3, 6 and 4, 6 it satisfy, it is the part of the object pixel, but 5, 6 it is not the part of the object pixel. So we will make a conclusion 4, 6 it will not be a part of the eroded output. Okay. Similarly if you perform the calculation for this pixel, this pixel, this pixel and this pixel, you will get the same conclusion that all these pixels will not be a part of the eroded output. Now we will take another pixel. Let's suppose we are taking this pixel. We will mark this pixel as the coordinate as Q, and the coordinate of Q are 2, 6. The coordinate of Q are 2, 6. So similar procedure we will repeat for the Q also. So Q having the coordinate 2, 6, and we have to perform the vector addition of 2, 6 with minus 1, 0, 0, 0 and 1, 0. So if you perform the vector addition of 2, 6 with minus 1, 0, my result would be 1, 6. If I perform the vector addition of 2, 6 with 0, 0, my result it is 2, 6. And if I do the vector addition of 2, 6 with 1, 0, my result would be 3, 6. Right? Now we will check whether 1, 6, 2, 6 and 3, 6 it is a part of the image set X or not. First for 1, 6, 1, 6 it is not the part of the input image set X. 2, 6 and 3, 6 both are the part of the input set X. So again we will make a conclusion. Since one of this coordinate 1, 6 it is not the part of the image set X, we will make the conclusion that Q 2, 6 it is not the part of eroded output. Right? So 2, 6 it is not the part of the eroded output. Similarly, if you do the calculation for all these pixels, you will get the same conclusion that this pixel, this pixel, this pixel and this pixel will not be the part of the eroded output. Next we will examine the center pixel. The center pixel, we will represent this pixel with R, having the coordinate along x it is 3, along y it is 6. So it is 3, 6. So similar procedure we will repeat for pixel R also. So R having the coordinate 3, 6. In the similar way, we will perform the vector addition with -1, 0. We will perform the vector addition of 3, 6 with -1, 0. We will get the result 2, 6. When we perform the vector addition of 3, 6 with 0, 0, you will get the result 3, 6. And when we perform the vector addition of 3, 6 with 1, 0, you will get the result 4, 6. Now we will check whether 2, 6, 3, 6 and 4, 6, whether it is a part of the image set X or not. So in the input image, if you find 2, 6, it represents this point, 3, 6 represent this point, and 4, 6 represent this point, and all belongs to the input image set X. So all belongs to the input image set X. Hence we will make a conclusion that 3, 6 it is a part of eroded output. So here we will make a conclusion that 3, 6 it is the part of the eroded output. In the similar way, if you do the calculation for this pixel, this pixel, this pixel and this pixel, you will get the conclusion that this and this will be a part of the eroded output. So in the output image, since only these 5 pixels satisfy the condition or the necessary condition of the erosion operations, so only these 5 pixels will be the part of the eroded output. So in the output image we will mark, these 5 pixels. So if you perform the erosion operation between this input image X and the structuring element B, you will get this much eroded output. Okay, so now again, similar to the dilation operation, again, if the number of pixels in the input image set X, it is very large, and similarly in the structuring element, if you having more number of pixels in the structuring element also, then this vector addition process, it becomes very complex and it becomes very difficult. Okay, so to overcome this issue, you can apply an analytical method also. So in this example, in the same example, we will apply the analytical method. This is my input image set X. This is my structuring element B. And here we have to plot, or here we have to draw the X erosion with B. So look at this structuring element. In this structuring element, the center pixel value, it is the shaded pixel. Considering this shaded pixel having the logic level 1. So center pixel, since it is a shaded, we will consider it having the logic level 1. Right side of the pixel, it is also shaded, we will consider it as also logic 1. Similarly, this left side pixel, it is also shaded, so we will consider it also a logic 1. So in structuring element, the center pixel value, it is 1. Right side pixel, it also having a logic level 1, and left side pixel, it also having the logic level 1. So this scenario you have to detect in the input image X. This scenario, it means you have to detect the scenario where the center pixel value, it is 1, right side it is logic 1, and left side it is also logic 1. So if you identify this condition in this input image, considering this pixel having the center pixel value logic 1, left side it is also logic 1, but right side it is not logic 1. So this is not the part of the eroded output. Similarly, if you do the calculation for all these pixels having the center pixel value 1, left side pixel value 1, but right side pixel value it is logic 0. So all these pixels will not be the part of eroded output. Similarly, if you do the calculation for all these pixels having the center pixel value 1, right side value it is also 1, but left side value it is not logic 1, it is logic 0. So all these pixels cannot be the part of the eroded output. Now coming to these 5 pixels, for these 5 pixels, center pixel value it is logic 1 since these are shaded pixels. Their left side pixels are also shaded, it means they are also logic 1. Their right side pixels are also shaded, it means they also having the logic level 1. So since only these 5 pixels satisfy the criteria, center pixel is also 1, left side is also 1, and right side is also logic 1. So only these 5 pixels will be the part of eroded output. So in the output image, you have to do the shading in these 5 pixels only. Okay. Let us take one more example. And I think now this example we will solve in just a couple of minutes. So in this couple of, so again, this is my input image X and this is my structuring element B. And here we have to draw the output X erosion with B. Since my input image having the dimension 8 cross 8, so here also I have drawn a output image having the dimension 8 cross 8. My structuring element having the center pixel value logic 1 since it is a shaded one, and outside 8 neighborhood pixel are also logic 1. So this scenario where the center pixel value it is logic 1 and 8 neighborhood pixel value are also logic 1, we have to detect this scenario in this input image X. So if you are going to search this condition in this input image X, only one pixel will satisfy the criteria, and this is this pixel. So for this pixel only, the center pixel value it is logic 1 and 8 neighborhood pixels are also having the logic level 1. So only this pixel will be the part of eroded output. So only this pixel will be the part of the eroded output, right? Now coming to our last example. In this example, again consider this is my input image X, this is my structuring element B, and here we have to draw the output of X erosion with B. Since my input image having the dimension 8 cross 8, so in order to draw the output of X erosion with B, here also I have drawn an output image having the same dimension 8 cross 8. Now look at the structuring element. In a structuring element, the center pixel value it is shaded, it means it is logic 1, and the 4 neighborhood pixels are shaded, it means they are also logic 1. So this scenario where the center pixel value is logic 1 and 4 neighborhood pixels are also logic 1, this scenario we have to identify in this input image X. So if you going to find such scenario where the center pixel value is 1 and 4 neighborhood pixels are also logic 1, you will get this pixel, this pixel, this pixel, this pixel, this and this. Only these 5 pixels satisfy the criteria whose center pixel value is 1, as well as the 4 neighborhood pixels value are also logic 1. So only these 5 pixels will be the part of the eroded output. So if you perform the erosion operation of this input image X with the structuring element B, this would be my eroded output. Thank you.